Okay, we're going to move on to problem 16. Draw a perspective drawing for a meso compound with the molecular formula C9H20. When we're drawing unknown compounds, it's great to do our EU straight off the bat. That way we know how many elements in saturation we have and whether we need to draw in rings or a double bond. So we have this formula here to give us our elements of unsaturation. It started off as 2C plus 20 plus 2, minus the number of H. H is halogens and hydrogens. C is your carbons or nitrogens, but nitrogens are only worth half a C. So let's go and solve this problem and to give us 0. Okay, so we have just linear branching, no rings or anything like that. So we have to draw a meso compound, knowing that we have no rings to work with. Meso compounds have that internal mirror image. So what this means is we're going to end up with the same thing over here as over here. They're going to have to have the same branching and everything for it to be a mirror image, and they're going to have to have an R and S relationship. So let's draw those chiral carbons. We know we have to have 2. And our first question becomes whether we need a carbon image on the internal mirror plane or if we need maybe 1 or 2. So let's try first to do it with no carbons in the middle, so just a straight line between these 2 chiral carbons. If we did it like this, we still have 7 carbons to work with because we've used these 2 as chiral centers. So if now we only have 7, we would have to divide that evenly to give us 2 equal-sided branch points or chiral centers. And that's not going to work because it's an odd number. And if we divided this evenly in half, we would end up with 3.5, and you can't have half a carbon. So what do we do to give us a more symmetrical drawing? We need to take away 1 more carbon, and we're going to put that in the middle of these 2. That way it's on the mirror plane and we still have mirror images. This is just on that plane of symmetry. So now we have 6. Again, you want an even number of carbons to draw for a meso compound on each side. And we can use the middle of the 2 to hide the extra carbons. So now we have 6 to draw out. And that means we have to divide that by 2 and end up with 3 for each side. With 3 for each side, we have to come up with 3 unique branches. Now, how do we do that? Because if we use all 3 of these, we would end up with a bunch of methyls, and we know that's not a chiral center. We're going to use hydrogen because we can use him as again. He's that free spot holder. So let's use 1 hydrogen here. It's always great to use them when you have to draw chiral centers because they will save you carbons for the other branches. We already have 1 unique branch point here, and the other branch is going to be these carbons over in the center that they're both sharing equally. So now we just need 2 more. And we have 3 carbons to make those 2, and that works out. We can have an ethyl group and a methyl group. And again, we draw the same stereochemistry over here. Oh, not the same stereochemistry, the same planes. To be mirror images like that, we have to have them both, the methyls both being dashes. And we want this to be that perspective drawing zigzag that we did there. That way we don't have to redraw this. Now we have 3 different groups, or 4 different groups. This ethyl, a hydrogen, a methyl, and then this complex branch. And it's the same on the other side. The only thing we have to make sure of now is that one side's R and the other is S, so they're mirror images of each other, because we know that they're the same thing now. So we'll number these. Let's see, this carbon is going to be our number 1 because it is attached to this carbon over here that has 2 carbons next to it. That's going to be more complex than this carbon with only 1 attached to it. Then this carbon's going to be 3, and hydrogen's 4. We could do our R and S by connecting these, and we end up seeing that it's R, but since our hydrogen's a wedge, that's really S. Okay, so we can delete those, and we know now that this side is S. On to the other side, we can number it like we did here. We know that the complex branch is 1, the ethyl is 2, and the methyl is 3. We go this way, and we end up with S, but since again our low priority group is wedged, it's really R. So we don't have to switch our dash or wedges to make them R and S. That means we can keep the dash, these two guys, these two drawings alike. A good rule of thumb is if the carbons are right next to each other and you have to draw a meso compound in perspective drawing, you need one to be wedged and the neighboring one to be dashed. That's because when you flip this on that single bond, you'll end up with them both being on the same plane. And if they're an odd number away, so if it was way over here, over right there, then we'd have to have them on the same, or on the same plane, so wedged and wedged. Okay. And again, it's always great to check just by doing your priority and seeing whether they're R and S. So we have our perspective drawing right here, and we can go off of that as our answer.